MiniMax's latest open-source model scores over 80% on SWE-bench verified, the toughest real-world coding benchmark in production. 30 cents per million tokens, 25 times cheaper than GPT 5.4 or Claude Opus. The weights are free. You can download them tonight. So the story you've heard goes like this. The gap closed. Open source caught up. Anyone can run frontier AI now. A hospital in Kenya, a ministry in Peru, a startup in Bangladesh. It's a clean story. And it's mostly wrong, because there's a brutal difference between downloading the weights of a model and actually running it, reliably, safely, at scale, for real users, in production. And that difference is where the real power in AI actually lives. 2 layers. That's all you need to see to understand why the democratization narrative falls apart. There's a weights layer, the actual neural network parameters. For several frontier-class models, these are now freely downloadable. MiniMax M2.5, DeepSeek V4, Qwen 3.5, Meta's Llama 4. Real models, competitive benchmarks, open weights. That part of the story is true. Then there's the deployment layer, the operational machinery you need to take those weights and turn them into something real. And that layer, the deployment layer, is where the binding constraint has moved. The democratization story is true about the first layer. It is not true about the second. And the second is where power actually lives. Let me walk through what it actually takes to run a frontier model in production, not as an experiment, as a service that a hospital, a ministry, a real institution can depend on. First, GPU infrastructure. For a 400 billion parameter model, you need clusters with enough memory and interconnect bandwidth to serve it at production throughput. That's not rental by the hour. That's capital investment. Hundreds of thousands to millions of dollars upfront before you serve a single query. Second, ML Ops talent. Model versioning, quantization, caching, batching, monitoring. These are not skills you hire junior. The people who can do this well work at hyperscalers, because hyperscalers pay accordingly. Third, safety tuning. Open weight releases typically ship without production quality safety guardrails. Somebody has to fine-tune for the specific use case, the specific language, the specific regulatory environment. That is skilled, expensive, ongoing work. Fourth, uptime and latency. A healthcare service can't go down for 3 hours on a Tuesday. That means redundancy, load balancing, failover infrastructure. The kind of operational discipline that hyperscalers have built over decades and most government IT departments have not. Fifth, cost per query economics. This is where the math gets uncomfortable. Hyperscalers amortize their GPU infrastructure across billions of queries per day. A national ministry, serving maybe a few million queries per month, pays a dramatically higher per-unit cost for the same hardware. The token price on the box says 30 cents. The effective cost of self-hosting, fully loaded, is multiples of that. Sixth, data governance. What goes into the prompts? What gets logged? What gets used for fine-tuning? What crosses jurisdictional boundaries? Under GDPR, India's DPDP Act, or any of the 20-plus emerging data residency frameworks, these are not optional questions. They're compliance requirements, and compliance has a cost that scales with complexity. Almost no organization outside a narrow band of sophisticated tech companies has all 6 of those things at once. So what actually happens, in practice, in governments and hospitals and schools and small businesses around the world, is that they rent They use hyperscaler APIs, Microsoft Azure, Google Cloud, Amazon Web Services, regardless of whether the model underneath is open or closed. This is the gap nobody names. Call it what it is. The inference-as-utility gap. It's the distance between having the weights and having a reliable, safety-tuned, locally governed inference service you can actually deploy to real users. And for almost every institution outside the hyperscaler client list, that gap is uncrossable at current prices. The consequence is structural. Open weights democratize the benchmark layer. They do not democratize the deployment layer. And the deployment layer is where the cost, the dependency, the oversight, and the profit live. So when someone tells you open source AI is democratizing the technology, the question to ask is this: democratizing which layer? Because if the answer is the weights, that's probably true. If the answer is the deployment, the market reality says it isn't. So what would change the story? What would actually democratize deployment? One thing: public inference services. Safety-tuned, locally governed, operated as public infrastructure the way electricity or water or roads are. Running on open weights with regional capacity, accessible to governments and SMEs at amortized costs, hyperscalers charge their biggest customers. It's not a fantasy. The technology is there. The weights exist. The operational playbooks exist. Hyperscalers have been running this for 15 years. What doesn't exist is the decision to fund it as a public good, at development bank scale, in the countries where it would matter most. One pilot in one country serving a national health system, running on safety-tuned open weight models with regional governance and transparent economics. Not a pilot program. A real production service with safety tuning, uptime guarantees, and governance standards. Every technology revolution has had a moment like this, when the thing that looks like liberation turns out to be a new form of dependency. The printing press liberated readers and enriched printers. The railroad connected farmers and enriched rail barons. The internet empowered publishers and enriched platforms. Open source AI fits the pattern. Free weights, owned services, and almost nobody is looking at the second half of that sentence.